So in this video, we'll be looking into the event loop as a whole, uh, in a summary-based, abstract-based, explanation. So, you know that JavaScript is an asynchronous, single-threaded language, right? So it basically, what single-threaded means that it will do one task at a time, right? So let's see how the browser looks like and the engines. I have made some drawings as well. So let's see what is actually how it actually looks like for a JavaScript. The whole browser. So this is, you can see the browser as such, and this is the JS engine. The JavaScript engine is for Chrome it is V8, for Mozilla it is something else, and for Edge it is something else. But every browser will have a JavaScript engine as such. So inside the JavaScript, there will be a call stack. You know that every JavaScript piece of code gets into the call stack and then it gets executed, right? So this is the call stack. And we have another thing called web APIs. So basically, I have listed down, there are many web APIs. There are many things, but some basic example that you use in a daily basis are like set timeout, DOM, fetch, even the console.log that you do is not these are not provided by JavaScript. These actually by the browser itself. And because the call stack, the JS engine and the web APIs are inside browser only, so they can easily access with the help of window, called a window. So if you do maybe a log of this, so this is basically the object. We are pointing to the object. So now this is basically pointing to my global object, which is the window object. So if I save this, you will get a window. So here each and everything will be there that is provided. You are doing alert, right? So it is not a JavaScript's own thing. It is basically a web API that the window object actually provides us, right? So you got the idea about what the web APIs looks like, right? So let's see how it gets executed. So for example, if you do maybe uh, okay, so if I do, for example, console.log one, and then if I do maybe a set timeout as such, set timeout, and if I give set timeout of 1,000, and if I do uh, log of inside the set timeout, and if I do a uh, log of 2 maybe, yeah. So how actually JavaScript runs the code. So the first code, so at the initial phase, if you don't whatever you write, there will be a global execution context, right? So right away, if you save this, the call stack will now, for now it is empty, but the thing is, as soon as you save it, it will just create a global execution context here, right? Then what will happen is that console dot this first line will be into the call stack, and what it will see that, okay, this is a console.log. What it will search for the console.log from the window. It will ask the window that window API, and it will go to the console.log, and it will search for the console. And in the log, for example, if this is my console.log, the UI, the inspect element, whatever you see in the behind of the Chrome. So this is the console. So it will search for the console.log API, and it will just simply print my output, right? So now what will happen is that it will go to line number 306. So it is now in the set timeout. Okay. So what it will do is it will it will also go into the call stack, but the thing is, it will right away move out. It will also get popped out, And what it will do is it will just remain here in the web API in the set timeout. Okay, so set timeout, now this thing knows that okay, this is a piece of code that I have to run after the this interval, right? So it will lie down here. So it will wait for his time. I mean his turn. Now before this, what it will do is the console.log will go into my call stack, right? So console.log, as soon as console.log will come into my call stack, so what it will search that, okay, I mean, console.log is not there. So it will search for the window object. Through the window object, it will search the console.log again, and it will get the console.log, and it will right away print the output, right? So in the output, you will get the 1 and 2. So what about the set timeout? So now after the 1 second, what it will do is, okay, so now here the concept comes about the event loop. So what event loop is, so let me erase these things. Yeah, these. Yeah. So event loop, you can say, is just like a security guard, you could say. So event loop just it's like a machine only. What it does is it actually maintains the call stack as well as the callback queue. Callback. So what is actually the callback key? So whatever you write, for example, the function and whatever you write, the function or maybe the object or maybe the variable or something. So what it will do is every piece of code, for example, if it's a function, this function will go into the callback queue. The first it will go to the callback queue. Now, what my let me point out this as well. For example, uh, this is the event loop. Event loop. Okay. So now the event loop will check, okay, now the call stack is empty or not. So right away when you when the console.log is empty, I mean it got executed. So before the 1 second, this global execution context will also get removed. Okay. So if there is nothing to, I mean, to give the output, the global execution context will also get popped out. So now after the 1000, what it will do is this callback will go into the callback queue. So it will wait for its turn to get executed. Now the event loop will check the callback queue. Okay, there is something inside the callback queue, and it will check the, okay, is my call stack is empty or not. If it's empty, then what it will do, it will just move this thing. So it basically, you can, by the name also you can know that it is a queue data structure, right? And there's a stack data structure. So whatever comes first, it will go first, right? So this piece of code, the callback will go into the call stack, and it will get I mean it will get executed, right? So this was the overall thing of the how this event loop actually works. So let's go into the code. Let's see what we can do with it. Let me remove this as well, and this as well, and these things as well. So okay, yeah. So if you see, now the output will be the 1, 2, and after 1 second, my inside the st will get print, right? So if I save the file, so 1, 2 got executed, and after 1 second, you will see that the inside the st got executed, right? But the thing is, there is a there's a I mean a differentiating factor, for example, differentiating factor, or you can say a filter as such, filter. So the thing is, for example, if you are maybe fetching some, one thing I think I forgot to tell you, that this web API or everything, I mean the web API is also handle actually handles the everything, I mean the connections and all. These web APIs have the local storage as well. This web APIs has everything you need to run in the browser. So it will basically connect to the server as well, and it will fetch the result as well, and it will show in the UI. So whatever you see in the Netflix, or maybe any streaming website, or anything you see, so it is just because of this web APIs, you can see, right? So there's a differentiating factor is that we during the fetching a result, uh, what happens is there is something called a microtask queue as well. So what event loop is kind of like, you can say, it's a biased thing. So it gives more priority to the microtask queue. So what is the microtask queue actually? So microtask queue is similar to the callback queue only. But the thing is here, the for example, there are promises, there are, I think, couple of things I would have to see. But mainly if you fetch something, so it will give you a promise, right? So the promises actually goes into the microtask queue. So whatever you for example, there is one code that has a function that is a normal function, maybe a set timeout or something. And if you have a maybe a fetch or something like a promise, then it will always give the more priority to the promise rather than the function, I mean the set timeout. So let's see how actually, I mean, how it happens. So let's take an example of set timeout. Set timeout only, and I'll give it a 0. And let's say I'll take a promise dot new promise dot resolve and promise dot resolve inside maybe I can write a, yeah, I can write a dot then as well. Promise dot resolve and then dot then log to resolve the promise, log resolve, and then dot catch. Yeah. Yeah. So now, if you see, let me comment on this thing. So if you see now, this is a set time node. Let's console this is, inside set out, inside the set timeout, and there's a promise. So you should be like you will get not confused, I would say, but the thing is you will think that okay, the set timeout will get executed first because it is on top of the it will get executed first, right? And the promise will get executed after this. So let's see the output. So what is the output? So there's the resolve, it is coming first, and the set timeout is coming at the, I mean, after the promise. So why this? So as I've said that promises, I mean, the promise or fetch, the fetch actually returns you a promise. So I've directly write the promise only. So if you write the promise, it will get higher priority because the thing is, it doesn't get into the I mean the callback queue. It actually goes into the the microtask queue. So what event loop will do is it will basically check for the callback queue. I mean the microtask queue first. So if there is some code inside the microtask queue, it will first go into the call stack rather than the callback queue as such.